Welcome to the channel Smart Farm Insight. Across the immense fields of Russia, where vast plains meet an often unforgiving climate, stretches one of the country's most vibrant agricultural scenes, the carrot farms. These orange roots thrive even under harsh weather conditions, painting the landscape in long, golden rows. Every year, Russia produces nearly 1.5 million tons of carrots, accounting for about 8% of global production, making it one of the largest carrot-growing nations in the world. Carrots play an essential role in Russian agriculture, both as a staple food and as an export crop. They are not just sold fresh, but also processed into products like juice, frozen carrots, and spices, which are shipped to markets across Europe and Asia. But before they reach those destinations, each carrot undergoes a long journey, one that begins deep in the soil. Russian farmers begin by choosing loose. The soil is plowed, leveled, and enriched with compost before planting. Planting typically takes place in April and May, when the soil temperature reaches between 5 and 8 degrees. Farmers use both manual and mechanical methods depending on the size of their operations. On large industrial farms, precision seeders are used to ensure even spacing, planting seeds at a shallow depth of 1 centimeter and keeping 4 to 5 centimeters between seeds. Rows are spaced 20 to 30 centimeters apart to allow air and sunlight to circulate. A remarkable piece of equipment widely used in Russia is the Strege Varix 4500 ridge maker, which forms consistent ridges in the soil. These raised ridges provide excellent drainage and help secure the seeds in place, creating ideal conditions for germination. With 6 planting rows and a compact folding frame, the machine is capable of covering large fields quickly while maintaining accuracy. Carrots are slow to germinate, often taking 2 to 3 weeks before green shoots appear. Within a month, the plants become visible, and by 6 weeks, they stand about 10 to 15 centimeters tall. Watering is vital during this early stage. Not too much to flood the roots, but enough to keep the soil evenly moist. Farmers typically irrigate once or twice per week, depending on rainfall, using drip irrigation systems to conserve water while ensuring deep root growth. Beneath the soil, the roots expand rapidly, storing sugars and nutrients. Proper weeding and thinning are essential at this stage. Farmers manually or mechanically thin the rows, leaving one plant every 5 to 7 centimeters to give each carrot space to grow straight and plump. During the summer months, maintaining consistent moisture is critical. A mature carrot consists of nearly 88% water, so regular irrigation ensures sweetness and crisp texture. After about 3 months, the carrot tops stand 45 centimeters tall, and the roots have developed their signature orange color underground. The fields are now ready for the most exciting stage: harvest. Carrot harvesting in Russia. On large-scale farms, however, efficiency is key. Machines like the Convey 1010 SE harvester from Lift have revolutionized the process. Equipped with super grip belt systems, this machine lifts carrots from the soil with minimal damage, even under difficult conditions. The built-in root cleaner removes clinging soil, while a large sorting table allows workers to separate carrots by size and quality as they move along the conveyor. The harvester's hydraulic loading system places cleaned carrots directly into boxes or trailers. A well-tuned harvester can cover up to 10 hectares per day, turning weeks of labor into just a few efficient days. Whether harvested manually or mechanically, the result is the same. Thousands of tons of vibrant orange carrots ready to move to the next stage, cleaning and processing. At the factory, the journey from soil to supermarket begins in earnest. Carrots first pass through a sand removal conveyor, where spiral or star rollers shake off dirt and small stones. This system ensures that only clean roots continue down the line. Next, high-pressure water jets and rotating brushes polish the carrots until their skin shines. Modern facilities use water recycling systems, which save resources and reduce environmental impact. After washing, the carrots move to automated sorting stations. Here, sensors and cameras assess each carrot for length, color, and shape. Advanced image recognition systems can even detect internal cracks or imperfections invisible to the human eye. The carrots are then graded into different quality classes. Some destined for the fresh market, others for juicing, drying, or freezing. The next step is weighing and packaging. Precision scales ensure that each bag or box meets export standards. Packaging machines wrap the carrots in mesh bags or shrink-wrap trays, balancing aesthetics, hygiene, and protection during transport. Labels and barcodes are printed automatically, allowing full traceability from farm to store shelf. For the processing industry, carrots undergo further transformation. At juice factories, they are peeled, chopped, and fed into hydraulic presses that extract rich carrot juice full of nutrients. The juice is filtered, pasteurized, and bottled for sale, maintaining its freshness and natural sweetness. Carrots destined for drying enter industrial dryers, operating at 50-70 degrees Celsius. In just a few hours, they lose most of their moisture, but retain their bright color and flavor. These dried carrots are used in soups, snacks, and seasoning blends, providing a convenient way to enjoy the vegetable year-round. Once packaged, the carrots are loaded into refrigerated trucks or containers to maintain freshness during transport. Many of these shipments head toward Europe and Asia, where Russian carrots are prized for their sweetness and quality. Carrots are not only a valuable export, but also a staple of the Russian diet. They are found in traditional dishes like borscht, salads, and stews, playing both a nutritional and cultural role. Carrot farming sustains thousands of rural communities across Russia. From machinery operators to factory workers, it provides steady employment and contributes significantly to local economies. Advanced technologies, such as automated harvesters and AI sorting systems, continue to enhance productivity while preserving product quality. Every carrot that reaches your plate tells the story of this journey. From soil preparation and precise sowing to high-tech harvesting and global trade, it's more than just a vegetable. It's a symbol of modern agriculture's progress and the connection between land, technology, and people. The United States, with its vast croplands and advanced farming systems, stands among the world's largest peanut producers. Each year, more than 7 million tons of peanuts are harvested from fertile alluvial soils across Georgia, Alabama, Texas, and North Carolina, forming the backbone of an industry that fuels both domestic and global markets. Behind every spoonful of peanut butter, every roasted snack, and every drop of golden peanut oil lies a journey that begins in the fields and ends in state-of-the-art factories. Let's explore that complete journey, endowing from planting to processing, and discover how America's peanuts become a global staple. The peanut season begins in spring, from April to June. When the soil is warm and free of frost, farmers start by clearing the field of weeds, stones, and crop residues from the previous season. The land is tilled and loosened, creating a soft, well-aerated environment for root growth. Soil tests determine pH and nutrient levels, with an ideal pH between 5.8 and 6.5. If necessary, lime is added to balance acidity. Organic compost or decomposed manure improves soil fertility and structure. Peanut seeds are sown about 2 to 3 inches deep, spaced 3 to 4 inches apart, with 36 to 48 inches between rows. This spacing allows sunlight to reach all plants and gives room for pods to form underground. In large farms, planting is done with precision machines equipped with sensors and metering systems that ensure consistent seed placement and depth. Once planted, the soil is lightly compacted to preserve moisture, promoting fast and uniform germination. Within 10 to 12 days, small green shoots emerge, marking the beginning of a 4 or 5 month growth cycle. Peanuts are known for their unique growth process. About 40 days after planting, the plants begin to flower. Each small, pale yellow flower lasts only 1 day. After pollination, the flower base elongates into a slender stem called a peg, which bends downward and buries itself in the soil. At the tip of the peg, underground pods begin to form, each containing the peanuts we eat. This stage, called pegging, is critical. The soil must remain soft and moist to allow pegs to penetrate easily. Farmers monitor irrigation carefully, providing about 1.5 to 2 inches of water per week through rain or pivot irrigation systems. As pods fill and mature, irrigation is gradually reduced, helping the shells dry naturally. Peanuts are usually harvested 120 to 150 days after planting. When leaves turn yellow and the pods develop their characteristic light brown color, farmers know the crop is ready. Modern peanut farms use specialized digger-shaker inverter machines to lift and invert the plants. The machines cut beneath the roots, shake off excess soil, and flip the plants upside down so the pods are exposed to the air. This allows the peanuts to dry naturally in the sun for about 3 to 7 days, reducing their moisture content from 35–50% to below 10%. In humid areas, peanut dryers circulate warm air to complete the drying process without mold or spoilage. Once dry, peanut combines separate the pods from the vines. Rotating drums inside the combine strip the peanuts cleanly and transfer them into hoppers for collection. In large farms, a single machine can process 8 to 10 hectares per day. Freshly harvested peanuts are transported by truck to buying stations, where they are received, weighed, and inspected. Technicians extract random samples from the load using pneumatic probes. These samples are analyzed to determine moisture levels, shell condition, kernel quality, and foreign material content. If the moisture is above 10%, peanuts are passed through heated air drying systems to achieve a safe storage level of 9 to 10%. At this level, peanuts can stay fresh for many months. Once dried and cleaned, they are classified according to size, color, and overall quality. At large-scale facilities in Georgia and Texas, peanuts undergo a series of mechanical and optical processes to separate and refine the kernels. The peanuts are first cleaned on vibrating conveyors to remove dirt and debris. They then enter rotating drums that gently crack open the shells. Through controlled friction, the kernels and shells separate and move through air columns, where lightweight shells are blown away and heavier kernels fall to collection belts. A gravity separator further classifies the kernels by density, ensuring that only plump, mature peanuts move forward. Next, optical sorting machines equipped with RGB and infrared cameras inspect each kernel individually. Defective or discolored peanuts are removed using air jets, leaving behind a batch that is 99.9% pure and uniform. The cleaned peanuts are then stored in climate-controlled silos, waiting to be processed into roasted nuts, peanut butter, candy, or oil. Selected peanuts are roasted in rotary ovens under controlled heat to enhance their aroma, flavor, and crispness. Once roasted, they move into rotating drums where seasonings such as salt, sugar, honey, or chili are evenly applied. A second drying step removes excess moisture and locks in flavor. Modern packaging systems then weigh, seal, and label the products automatically. Representing one of the fastest-growing sectors in the industry, peanut butter, one of the most iconic American foods, is made from finely ground roasted peanuts. It takes around 1,000 peanuts to make a single 500-gram jar. After roasting, the peanuts are cooled and sent through blanching machines that remove their thin brown skins. Color sorters eliminate over-roasted or damaged kernels, leaving only perfect ones for grinding. The peanuts are then fed into high-speed mills, where they are crushed into a smooth paste. During grinding, salt, sugar, and a small amount of hydrogenated vegetable oil are added to maintain flavor and stability. Friction from grinding naturally heats the paste to about 60 degrees Celsius, so it is cooled to 30 degrees Celsius before being filled into jars. Once sealed and labeled, jars can remain fresh for up to 9 months at room temperature. Peanut kernels contain up to 50% oil by weight, making them a valuable source of cooking oil. After cleaning and drying, the kernels are pressed in high-pressure expeller machines. The mechanical force extracts the oil. While leaving behind a dense peanut cake used for livestock feed. The raw oil is filtered multiple times through vacuum or membrane filters, removing impurities and solids. It is then refined and deodorized to improve clarity and aroma, before being bottled automatically in steel or plastic containers. Peanut oil's high smoke point and neutral taste make it a favorite choice for frying, cooking, and food manufacturing across the globe. American farms are increasingly focused on sustainability, using moisture sensors, crop rotation, and efficient irrigation to conserve water and maintain soil health. The peanut industry supports tens of thousands of American families, from farmers and transport workers to processors and exporters. Peanuts are shipped to markets around the world where they are transformed into hundreds of everyday products. A story of patience, precision, and pride in turning one humble legume into a global treasure.